So just I'm going to discuss about 4 topics today. First one is Golden Gate architecture today I'm going to discuss, and second thing is what are the ways to synchronize source database and target database. That is the second point. And third point about more details about Golden Gate components. These are the things which I'm going to discuss today. And as a part of that, now I'm going to discuss about the synchronizing methods available in Golden Gate. So let's take an example. These are source database, and I have a target database over here. So I need to synchronize these 2 databases. So what are the ways we have to synchronize these 2 databases? So mainly we can say there are two ways. One is chain synchronization. Second one is the initial load. In these 2 ways, we are going to synchronize both the source and target databases. So let's discuss about chain synchronization. What is the chain synchronization? Chain synchronization is nothing but synchronizing current transactions, whatever happening at a source, with the target. That is nothing but a chain synchronization. Say for example, you have a database in India, and you have a target database in US, and you need to synchronize whatever the transactions currently happening in the Indian database. Suppose if you are synchronizing those transactions with US database, that itself is nothing but a chain synchronization. For that, we need to configure different components of Golden Gate. Say for example, extract we need to configure. We need to configure remote trial files, and we need to configure the replicate process at the target. So to achieve the chain synchronization based on our business requirement, we will design a Golden Gate components, and after that, after designing those Golden Gate components, we will configure as per the design. Okay, so just I'm going to explain the chain synchronization, how it is going to happen. As I mentioned here, we have a source and target database, and what I'm going to do is just I'm going to configure extract in the source, and in the target we will have a collector process over here, and collector process will send those collect those changes whatever extract is sending from source, and it will write in the form of remote trial files. And once the remote trial files are available, here one replicate process will be available. So this replicate process will continuously read these trial files, and it applies to the target database. So this is one way of synchronization, like one way of chain synchronization. Say with this method, I mean, like by saying this method, it looks very straightforward, and there won't be any delay, and it happens in an efficient way. However, there is a limitation with this method. What exactly the limitation is? So suppose if there is any problem with the network, or if the target system is down, so extract cannot pump all those changes whatever it is collecting from the source database, because there is no endpoint to collect the changes whatever extract is sending. So automatically what happens? There will be a break in the transaction, because extract cannot hold any transaction itself. What it does is simply it captures the changes whatever available in online redo log files, and it pumps the details to collector file. So over the period of time, say for example every 20 minutes or 30 minutes, online redo log files will be overlapped as a part of log rotation. So what happens? Extract cannot read old transactions whatever present in earlier online redo logs, because those are overwritten. So extract cannot capture the old transaction, so it cannot send to collector once, after some time. Say, let's take an example: a target database, target site is available, the issue got resolved, but extract cannot extract old transactions, because those transactions wherever those present in online redo logs, those got overwritten as a part of log rotation. So this is the limitation with this method. In this, yeah, Mukesh, I will come to that point actually. I will explain you. I saw Mukesh. Can we write locally and use pump extract to send the target host? Yes, I'm going to explain that option. This is one of the method available. So just I'm explaining that. Once it is available, I'm going to explain that other method also using data pump. So this is a limitation with current method whatever I explained. Like where there is no staging point in the source. So whatever transactions happening on the source, extract those transactions and it will directly send to the collector. So there is no staging location on the source because of network problem or because of the target is down or some any reason. If collector is not able to collect the files from the extract, automatically what happens is the changes will be lost and we cannot replicate it. So this is the main disadvantage with this method. So there is one more method through which we can stage those files in the source machine, and we will configure another component called data pump in the source. What it does is that it will pump the files to collector. So what happens in this method is as and when any transactions happens, keep extracting those transactions from the online redo log files and it places into the local storage in the form of files. Those files will be called as the trail files, and since those are created in the source location, those files also will be called as extract trail files also we can call. Okay. And after that, what happens is that we will configure a data pump in the source location only. We will pump them to collector. So just I'm going to show you the document diagram so that you will have a better idea. Okay. See, this is the diagram. If you see this extract and this is the collector. So this left portion is completely source machine. And the right portion is completely target machine. Okay, and both are separated by a network. If you see the lower portion of this diagram, I am going to explain about this portion now. This is nothing but a chain synchronization. Here we have one extract on the source machine. Directly it is sending to the collector process. What collector is doing is it is placing those changes in the trial files, that also called as a remote trial files, and there is one more process called replicate process which will apply those changes to the target. This is the direct method. With this method, the limitation is if there is any problem with this network or if there is any problem with this target machine, the changes whatever extract is collecting, it cannot send to the collector because a collector is not accessible or collector is not available. So what happens? Extract cannot store those changes within itself. So those changes will be lost. So that is a limitation. To overcome that limitation, we have another option called configuring the data pump. So how we will do? By the way, this is an optional. It's not compulsory, like configuring the data pump as well as the trial files on the source. This is an optional configuration, but it is the best and advised solution, recommended method from Oracle also. So what we will do is, extract sends those changes into the files. Those will be called as a remote trial files. And we will configure another process called data pump process, and what it does is it collects these changes from these trial files and it will send to the collector on the remote, and the rest of the process is same as it is. So what we can say is chain synchronization can be implemented in two ways. One is directly extract is sending the detailed changes to the collector. Another one is through data pump we can do. However, out of these two methods, data pump configuring through data pump is the recommended and advised best approach, because we don't lose any trial files. Okay, and another point is over here. This data pump means You might have heard about a new a utility from 10G onwards, that is a data pump. There is one more data pump concept over there, through which we can export the data and we can import the data. So that data pump is different than the data pump what we are discussing in Golden Gate. This data pump is a simple process similar to the extract or collector or replicate. It is not a tool, whatever we discussed in the database concepts, whatever we know in the database concept. In database concepts, that data pump is like export DP or IMP DP. That is a tool to transfer, migrate the data from, or export or import data from one machine to another machine. But this data pump is, the data pump what we are discussing in Golden Gate is, it's a simple one background process which reads the trial files and it sends to the collector. So this is a different data pump process. Okay, I hope everybody is clear with this chain synchronization. If any doubts, just let me know in the chat so that I will explain you on that point. Otherwise, I will move on to the initial load. Okay, seems nobody having any doubt on this. So let me move on to the initial load. Okay, before explaining initial load, I will give an example so that what happens, you will get a better idea of why initial load is required. Okay, let's take an example. We have a Scott schema and we have an employee table. And employee table is having 14 records. And today you configured chain synchronization on source and target. Say for example, you inserted one record and the same thing is reflected in redo log files. So redo log files, the change is reflected in redo log files means extract in the source, captured it and sent to target mission. Okay, and collector received in the target and it applied on the replicate process applied out on target. So source table is having 14 and plus new record, 14 plus 1, total we have 50 records. In the target mission, we don't have any data, so we have a new record, this newly added record. So we have one record in the target database. Again, user added one more record, that is insert 2, we can say. And the same transaction is reflected in redo log files. And extract process read that file and it's sent to collector, either through data pump or direct method, we can say, in either way. And replicate process on the target mission applied to the target mission. So total we have 2 records in the target and in the source we have total 16. But our objective is to synchronize both the databases, like source database as well as target database. We need to synchronize both the databases. But currently we are able to send the transactions, whatever the current transactions are happening, those transactions we are able to send to the target because we have only chain synchronization so far. Okay, so through chain synchronization, we send whatever the transactions currently happening, those are replicated to target database. Then how about the existing data, already existing data? We don't find those information in the redo log files because those records are available since a long time, and those transactions already fleshed out from redo log files. We don't find it, and our current chain synchronizations can able to read only redo log files, and what it does is it is going to replicate those changes whatever currently happening in the source database. Those only will be replicated to the target mission. So then how we are going to synchronize existing data, not the current transactional data. For that, for synchronizing existing data, we have a concept called initial load. With initial load, what we are going to do is we are going to synchronize existing data whatever available in the existing tables. Say for example, in employees table, before change synchronization, we have total 14 records, and user did 2 transactions. Through 2 transactions, he did 2 inserts. So those 2 transactions are replicated in the target machine using change synchronization method, whatever I discussed just before. And for those 14 records to synchronize with the target, we need to configure initial load. So that has been shown in the upper part of this diagram. See how we configured it. I am going to discuss in details about that. There is one extract process on the source machine, and there is a replicate process on the target. See here, there is no trial files, nothing. Of course, if we require, we can configure it, but it's not compulsory over here. With the initial load, what happens is that extract directly reads the tables instead of redo log files. Okay, and it sends directly to the replicate process on the target, and replicate process directly inserts those records into the particular tables. So this is the way it is going to happen with initial load. So initial load will be used to synchronize existing data in the source to the target. So for that purpose, we are going to use initial load. And I already explained about the change synchronization. Change synchronization is nothing but synchronizing current transactional data with the target database. For synchronizing existing current transactional data with target database, we will use synchronization and change synchronization. And change synchronization can be done in 2 ways: through direct method, so there won't be any data pump. Extract will be configured in the source, and in the target we will configure the replicate, and it pushes the data to the collector, and collector will create a trial files, and trial files will be read by replicate, and replicate will use the replication method to target. Other way is extract will write the files into the local trial files, and data pump will read those local trial files, and it sends to the collector. And collector creates the trial files. Those will be called as remote trial files also. And replicate process will read those remote trial files, and it applies to target database. So this is about the change synchronization. So wherever you go in the Golden Gate configuration, mostly you will have the same configuration everywhere. So if you understand this diagram clearly, so almost in all the scenarios in the Golden Gate, we are going to implement almost similar to the same with the slight modifications here and there. Maybe you may have more data pumps, or you may have more extracts, or in the target location you may have replicates more. In the with the slight variations, you will have the same configuration everywhere. Okay, so this diagram is a little bit important. If you understand this diagram, I think Golden Gate is almost runs around the same diagram. And now I am going to discuss a little more about each component today, so that after that we can wind up all the theoretical part, and we can move on to the practical sessions from next week onwards. Yesterday,
this is Mukesh here.
Yeah, Mukesh. Yeah, you can type the questions whatever you have, Mukesh.
Okay. So I can. Do you want me to chart that? I mean.
Yes.
Yeah, sure.
Yeah, are you typing, Mukesh?
I'm updating.
So what we are currently doing is like we are syncing up the database using ADG and then activating the ADG. So we haven't tested because I'm not sure it will support for 80 terabyte database. So that's the reason.
Yeah, we will discuss those concepts later section, Mukesh. Mukesh, or Krishna, your name is?
Mukesh, yeah.
Yeah, but I'm getting the updates with the Krishna name.
Yeah, I mean, I posted question, and after that, then there is from Krishna too.
Okay.
Yeah,
And actually, I see all the connections are muted, but still I'm able to. Okay, you unmuted from your side. Okay.
Yeah.
The same question you are able to. You are looking. Am I right, Krishna? I'm sorry, Mukesh.
Yes.
Oh, okay. Okay. Now, let's discuss about the extract and those other components, whatever we have in the architecture diagram. Okay. So, extract, whatever we discussed earlier. So, extract, we will configure this extract parameter, extract process in the source machine to extract the changes directly from the redo log files or directly from the tables. So this will be available in the source machine, and its main purpose is to capture the changes whatever happening on the source machine or to capture the existing data from the source tables. Okay, so this we will configure based on our requirement, and we can have more than one extract. So what happens is that if we have more number of transactions happening in the database, and if we see that there is a latency, or if there is because of any other reasons, if the synchronization is not happening because of heavy load, and if required, we will increase the number of extracts in the source machine based on the load. And it's completely based on the scenario. It's not like we need to have more number of extracts. It's based on the completely load. We will have more than one extract. And we can have more than one, like extract can support more than one table also. And we can configure for entire database also one extract for entire source database. Or we can have separate extract process for each schema. So based on the requirement, we will configure the extract files over here. And the next component is okay. And one more thing I would like to update you on this extract process is okay. See, if you see this diagram, say for example, we have a source database over here, and the transactions are happening over here, and those transactions reflected in redo log files, and I have configured one extract over here, so which keeps monitoring the redo log files, and it creates trial files, or it pushes to the collector process. So what happens over here is this extract process mainly sends only committed transactions, not the uncommitted transactions. But it reads all the transactions, whatever it is saying in the redo log files, but it will send only committed transactions to the other end. See, I mean, like whether it sends to the collector or it writes to the trial files, it only writes only the committed transactions, but it will not write uncommitted transactions. How it is happening is that it will have local buffer within it. It reads all the transactions, whatever it is saying in the redo log file. What it does is, whatever the committed transactions it says, those only it will send. So suppose if something is there, some transaction is there which is uncommitted transaction, what it does is it is not going to send it. So it will retain it within the buffer. As and when the transaction got committed, so then it will send in the same order in which it got committed. Okay, so that is about okay. So in the similar way, like the extract process sends only the committed transactions, not all the transactions. Okay, so in this way, the transactions will be filtered at extract level itself. Okay, and the next point is, say for example, let's take an example over here in this diagram. We have let's take total 4 transactions happened over here. So transaction 1, transaction 2, transaction 3, and transaction 4. So transaction 1 has not been committed, but transaction 2 is committed, and transaction 3 has been committed. So, however, our extract reads all these transactions because those are reflecting in our redo log files. But however, only 2 transactions got committed. So whatever those 2 transactions committed, those will be sent to the trial files because those are committed. See here, transaction 2 is committed and transaction 3 has been committed. So those will be sent to the trail files. And transaction 1 and transaction 4 happened, but those not got committed so far. So those will not be placed into the trail files. And the second point is that the order will follow the way how those got committed. Otherwise, it will not. It will follow the same order in which they were committed. They are committed. Okay, and the next point is, and what are the stages available for this extract process which we configured in the source machine? Extract can be in any of these 4 states. Either it can be in a stopped state, or it can be in a starting state, or running state, or abandoned state. Let me discuss with you each stage in a little detail. So when you configure any extract process in the source machine, what happens? It will be in a stopped state. So when you start, automatically for a fraction of seconds, it will be in a starting state and it will move on to the running state. Suppose because of any reason, extract is not able to, extract has been any reason, like if it is not able to extract, or if it is not able to pump the details to the target, or any various scenarios, extract process will abandon that process and it will go to abandoned state. So then we have to see the log files and we have to rectify that issue. After that, we need to start the extract process. However, if we configure automatic startup for this extract process in manager configuration, then what happens is automatically once you resolve the extract process, automatically it will be started automatically by manager process if we configure auto restart of the process. Okay, so that is a basic details about the extract process. Okay, so let's discuss about the data pump now. discussed in the diagram earlier, data pump is an optional component, means that you can configure a data pump or you can skip that. But basic purpose of this data pump is to read the local trial files and pass it on to the collector which is running on the target machine. So what happens is, like, data pump is nothing but it's also one of the background process. It's similar to the extract or replicate process, and it runs in two modes. So one is a pass-through mode. Another one is no pass-through mode. So these are the two modes in which data pump runs. What exactly the pass-through and no pass-through? Basically, data pump, what it does is that it just reads the trial files and it information. Who joined? Okay. So what it does is it reads the trial files in the source location and simply passes all the transactions. It will not do any filtering at a data pump level. So suppose if it is passing all the transactions means all committed transactions without filtering, so that means that's a pass-through. Okay, so either the data pump can send all the committed transactions directly to the collector process, or it can filter at that level itself. So means it can pass only specific table related transactions, or it can pass only specific records only, specific meeting certain criteria. So those transactions only it will pass to the collector. Suppose if it is filtering at a data pump level, like sending the transactions related to the particular tables or sending the particular records which meets the specific criteria, if it is doing a similar kind of filtering at a data pump level, so then we will call it as a no pass-through method, we can say. So these are the two modes available for in data pump. Okay, so what are the why we are using data pump means I already discussed with you. So with the data pump, if there is any network related issues at the in between servers, or if there is any problem with the target machine, we can still have those changes in the form of local trial files, and data pump will send as and when network is available, or as and when target machine is up and running. So this is the main advantage with this data pump. There are many other applications like consolidation, and based on business requirement, we can use like synchronizing the different targets. There are different ways. So, but basically we can say to avoid the direct transmitting transactions between extract and collector, we will use the data pump option, so that we can safeguard all the transactions. Okay, next move on to the replicate process. And one more thing, data pump mostly it will be in the source machine only. Okay, so let's discuss about the replicate process, which is in the target machine. So replicate is also similar to the other processes like extract and data pump. It's also one background process. However, this will be configured, in the target machine itself. So the main its main role is just to read the trail files located in the target, whatever it received in the target machine,
simply it applies those transactions to the target database. So basically, it applies the transactions in the target database. So it is not like it's similar. It's like applying all the transactions whatever it comes to the trail files. However, it has one component associated with is one checkpoint file. Checkpoint file, as I mentioned yesterday, it's like one file created in the target mission for each replicate. What it does is it writes what is the write position, what is the read position. So what will happen is that it will have a track of the transactions, whatever it is recording over there. So what happens is that in case of process failure, when we restart that particular replicate process, it will reread that checkpoint file, and it finds like, okay, I completed up to so and so transaction, so it will move on to the next transactions. So that is a use of control checkpoint file, and replicate process will have that particular checkpoint file associated with that. Okay, and replicate process also can be in 4 stages. One is like stopped state, and the second one is in starting stage. Third one is like running stage. Fourth one is abandoned state. So as I explained earlier, the same way here also, initially when you configure replicate process, it will be in a stopped state, and second one when you are starting state, and if it is able to do the transactions to the target database without any issues, it will be in a running state. Suppose if because of any reason if it is not able to apply those transactions to the target database, it will be abandoned state. Suppose if it is in abandoned state, what we will do is that we will check the corresponding log files located in the Golden Gate home, and we will rectify those issues, and then we will restart the replicate process. So automatically again it will continue to replicate those changes to the target database. So this is the main functionality of replicate process. So this replicate process we will configure it in both the ways, like during the initial load also we will configure, and we will configure the chain synchronization also. Okay, and the next one is trial files. So the trial files, as I explained you earlier, those are the normal files which contains all the transactional information. However, this is managed by Golden Gate itself, and it's in the form of binary files, like UDI something format is there, universal data encryption or something. Universal data format, UDF format. What happens is that whatever the transactions happening, it will write in its own proprietary format, that is nothing but a universal data format. So what it does is that it will write those transactions in the form of in the order of committed order, and that will be read by only Golden Gate processes. We cannot read directly since it is in a binary format. Okay, and we will have 2 types of trial files. One is those trial files got created in the source mission by local extract, and another trial files are like created by collector process in the target mission. So the trial files, whatever we created, let me show you the diagram. Okay, so the trial files, whatever got created over here, those will be called as the local trial files or extract files, we can say. So those are created by local extract, this extract, which is running from source mission. And there are one more trial files called remote trial files. Those are created by collector process, and those will be available in the target mission. And coming to the trial file format,
what happens is the trial files are created with numerical numbers. 6-digit numerical number will be there. So 0, 0, 0, 0, 5 times 0, 1, starting with that, and it goes up to 6 times 9. So once it reaches to 6 times 9, automatically it will be, it will start with 0. I think that's a huge number, 6 times 9. So there won't be any issue with that. And each trial file will be prefixed with any prefix, whatever we specify. So as you know, as a like as a part of configuration, we will specify what is the prefix we should use. So accordingly, the prefix will be created. So for example, suppose if we specify trial file as with tr. So what happens is that our trial files will be created with 6610001, similar to like tr 6 times 9. So in a similar way, trial files will be created with the specific format. Okay, the next point which I'm going to discuss is checkpoint. See, so far we have seen 3 processes. What are those? One is extract process, another one is a data pump process, and third one is a replicate process. So the basic purpose of these 3 processes, somehow they will read the transactions, and it will send or it will apply to the target database. These are the main activities those are doing. So there should be a mechanism to track which transactions it read and which transactions it write. So in order to maintain that mechanism, that tracking, so each process, like each extract and each data pump and each replicate will have their own checkpoint file. So the checkpoint file is nothing but a tracking all the transactions, where it is currently reading and where it is writing. So that information will be available with a checkpoint for each process, that is extract and replicate. Extract will have its own checkpoint file, and data pump will have its own checkpoint file, and replicate will have its own checkpoint file. So whenever any problem happens to the extract process or data pump process or replicate process, so it will go to abandoned state, and after that when we restart it, it reads the checkpoint file, and it will get the information where it is currently writing and where it is currently reading. That information it reads from the checkpoint file, and accordingly it will continue its operation. Like extract means it keeps reading the online redo log file, and it will push the subsequent transactions to the local trial files, or it will send to the collector process. And data pump means again when we restart it, automatically it will read the current read and write positions from the checkpoint file, and accordingly it will continue to read these local trial files, and it will push those transactions to collector process. Similar, the replicate is like, when we restart the replicate process, what it does is that it reads the checkpoint file and about the read and write locations, and accordingly it will continue to apply the details to the apply the transactions to the target databases. So the checkpoint file is a normal text, not text file, but it is a file managed by Golden Gate. In addition to that, replicate can have its own copy in the database also. Extract cannot have any checkpoint table in the database, or it cannot have multiple copies of checkpoint file, and data pump also cannot have multiple copies. But whereas replicate can have another copy in the form of database table in the target database. So that is only the difference with respect to checkpoint here. Otherwise, the rest of the details will be the same across all the processes. Okay, and okay, now let's discuss about the manager component, the next component. Okay, so as I mentioned earlier yesterday, the manager component is the main component which is available across all the databases, whether it is a source database or whether it is a target database. Manager is a compulsory object. So suppose in case of extract or replicate or data form, it's optional. It's not required to configure in every machine. So for example, extract is there. We will configure it in source machine, but not in the target machine. For example, replicate is there. We will configure it in source machine, but target machine, not in the source machine. Data form is an optional. If required, we can configure it in source machine. But whereas manager process is not like that. Manager process has to be available in all the instances of Golden Gate, like in all the database locations, because it is a master and it controls all the rest of the configurations configured in that specific Golden Gate environment. So say for example, in our diagram, in the source machine we have one extract and one data pump over here. So we have one manager. So this manager will control this extract files as well as this data pump, and in addition to that it manages these trail files also. I will explain how it is managing these trail files. In the target machine, so this manager is there. Manager is going to manage this collector process as well as the trail files as well as the replicate process. Okay, so I hope you understood the function, managing other components means whatever we configure in that specific environment, so those components will be managed by that particular manager. Okay, and in addition to the managing these processes, suppose if we specify automatic auto restart of components, means automatically if any specific component goes down, like extract goes down or if data pump goes down, automatically it will try to restart those components by itself without user intervention. So that also it does. And second one is it prepares the report internally, how many transactions completed today or in this particular hour or in this particular time period. So those kind of reports also prepared by manager process, and it places that information in the respective reports. And third one is also like it maintaining the trail files and log files. Trail files means, so as the time goes, automatically so many trail files will be created and those will be read by data pump, and in the similar way in the target location, the trail files will be read by replicate. And so it keeps accumulating the trail files. So there should be some mechanism to maintain these trail files, like purging the old trails and how long we need to maintain, etc. We will design a retention period, and based on that we will specify to the manager. Okay, every 2 hours or every 3 hours. Or like older than 3 hours or older than 4 hours. Like that we will specify in the manager file, and automatically it will purge those files. And next one is like if there is any errors in the extract files or extract process or a data pump process or replicate process, automatically it writes to the log files available in the Golden Gate home. So what happens is that users directly can go to that log file and they can understand why the specific process is going to abandon state, like it is extract or data pump or replicate process. So we can rectify that problem and we can start the affected process manually, or manager can start automatically once the issue has been resolved. And coming to the manager process status, manager will be in 2 states. One is in stopped state or running state. So those are the only 2 states about the manager process. Either it will be in a running state or stopped status. And the second point is this is the component which will be started at first in the Golden Gate configuration. Either it is in the source or target. Rest of the components will be started automatically once the manager has been started. Okay, and now let's move on to the collector. Just before going to the collector process, just let me take a 2 minutes break and I will continue with the collector process and rest of few small other components also there. We will discuss about that. Yes, I am holding the recording for 2 to 3 minutes. Okay, Mukesh. Okay, it's 9 digit in latest version. Okay, I'm not sure. I haven't aware of that. Thank you. Guys, I'm back. Okay, so I covered all the components except collector component in the diagram. I covered about the extract, manager, data pump, trial files. Except collector, I covered everything. So now I'm going to cover about the collector. Collector, basically it is available in the target mission, which generally collects all the changes, transactions sent by either extract file or data pump process, and it will write them into the target file, trial, remote trial files. That will be started automatically by manager itself. We will not configure collector by manual. We will not configure any specific configuration separately from our side. It will be managed by manager itself, and it will be started and stopped by manager itself. We will not specifically start collector. Of course, if required, we can do, but automatically it will be handled by manager itself. So the main purpose of this static collector is it's to collect the transactions from the source machine, like either from extract or either from data pump. So what happens is that as and when data pump needs to send any trail files to the remote machine, or if as and when extract needs to send some data to the remote machine, what it does is that it informs to the manager of source machine saying that I need to send so-and-so data to so-and-so machine. So what happens that manager process in the source sends a request to the manager process in the target machine saying that, okay, we need to send so-and-so information, please start the specific collector. So automatically manager process on the target machine start the respective collector. Then extract keeps sending the information to the collector, or data pump sends the information to the collector. So once it is done, again it will notify us, so then collector will be shut down. So this is a component which is completely managed by manager, and it's a dynamic process by default, dynamic collector we can say. And this is available only in the target machine, not in the source machine. So with this, we covered basic configuration about the all the components available in the golden gates, like we covered extract, data pump, replicate, trial files and checkpoints, and manager and collector. So apart from that, there are few things which we need to understand about golden gate. Those are like golden gate prompt. The way how we have a prompt in SQL, like SQL prompt is there, am I right? So the similar way, we have a golden gate prompt also. Like in the SQL prompt, we have a SQL prompt. In the similar way, in the golden gate, GGSCI is the golden gate prompt. So that is nothing but a golden gate software command interface, we will say. So through which we will configure from that golden gate prompt only, GGSCI prompt only, we will configure all the components. Either it could be extract, or it could be data pump, or replicate process, or starting the manager, stopping the manager, checking the status. Everything we are going to manage through golden gate command interface, that is golden gate prompt GGSCI. So this is a text-based version, and if we need, we have a graphical interface also. I think golden gate director or something is there. So that's a graphical interface. Through graphical interface, we can configure and we can manage those components in a graphical way. So that is the golden gate director. Okay, so most of the time I used to work with the golden gate GGSCI prompt only. So whatever the transactions, whatever the configurations we need to do, we will do it at golden gate prompt itself. So we can manage them easily. And the next component is def gen. Okay, so this def gen basically used to generate the table definitions in the golden gate environment. So for example, if we need to do the replication between two non-homogeneous databases, like Oracle to SQL Server or SQL Server to Oracle, or different databases, during the situations we will use def gen to create the table definitions, and after that we will do the replication. So suppose if we are doing the replication between the same databases, like it's Oracle to Oracle or SQL Server to SQL Server, we will not use def gen because there is no need of that.
Okay, and this is a utility. Okay, so through which we will generate the table definition. And next one is there is a utility called log dump also. Just I'm giving a brief idea about the available tools so that we will have a minimum basic idea about these tools. That is the reason I'm giving a little bit about all these components. Next one is log dump. So log dump is basically to read the Golden Gate trial files we will use, so that we can able to see that the information, whatever the information is available in the log file, that we can see that. And the next one is very data. So very data is also another product similar to Golden Gate, but with the very data, what we can do is just we can verify whatever the transactions happening, we can verify with the very data in the source as well as in the target. So it's a suite of products. It doesn't come with a Golden Gate, and it requires a specific license for using for using very data, and the additional cost is also involved in that. And next one is director. Director we already discussed. It's basically used for what it is, configuring all the components in the Golden Gate environment. And it's a GUI environment. I think somebody is doing it. Okay, Mukesh, I'm not aware of 12 latest version. Yeah, thanks for that update regarding the DevGen. Thank you. Mostly, I'm focusing about the 11G version. If any points I came across, I will give you an update on the 12C. And if anybody having any inputs also, just you can give me that information like the way how Mukesh is giving. Thanks, Mukesh.